Each of the following three data sets represents the IQ scores of a random sample of adults. IQ scores are known to have a mean and median of 100. So here are my three sample sizes. For each data set, compute the mean and median. What is the mean of sample set 5? So it's going to ask, I think, for the mean of all three of these and then the median of all three. We can do all that all in one swoop. We'll go ahead and open this up in StatCrunch. Here are our sample sizes. I can expand that just to make sure I see that, the titles of these. Okay, let's go ahead and go to Stat, Summary Stats, Columns. Let's just do all three at the same time. There's all three. It's only going to ask for the mean and the median. So if I want to, I always do N, hold down Control, and then do N, mean, and median. You didn't have to do that. We could have taken the defaults, but just to show you, you don't have to look at all of them. And here we go. So here is the mean. So for this first one, what is the mean of 5? Here's the mean of 5, 103.4. Now what's the mean of 12, and so on. The one thing you want to be careful on this one is that last one, the rounding. So mine came out to be 101.97. So when I round that to 1, that slips it back over to 102. A little quirky rounding thing. You may get different data sets, so that may not happen to you. But I did have to think for a quick second on that. Now go ahead and pop in the medians. Okay, so nothing really new on that one. Now it says for each data set, recalculate the mean and median, assuming the individual whose IQ is 107 is accidentally recorded as 170. So what is the mean of the new sample of size 5? So I'm going to go through here. Let's go ahead and just X out of that and change all of these. Ones that say 107, change them to 170. So this is 170, and then this one's 170. Okay, now I could go ahead and redo that. Let me show you something else you can do. I can pull that back up. Now, it hadn't changed yet, but watch this. I can go to Options and refresh, and here are my new values. So what is the new mean for the sample size of 5? Well, the new mean for mine is 116. And how about the mean for the sample size of 12? Mine was 105.4. And then for 30. And mine was 104.1. Now do the same thing with the median. And so now we need to make an observation. So for each sample size, state what happens to the mean and the median. So what did we notice happens to the mean? Let's see, my choices are the increase, decrease, stayed pretty much the same. So let's look at it for n equals to 5, for instance. My mean was at 103.4. And then when I redid it, my mean was 116. Similarly, for sample size of 12, it's 100.2. And then when I redid it, it was 105.4. And then for sample size of 30, again, I'm just comparing. Mine was 101 that's the median. Here's my mean, 100.2. And the new mean here was 105.4. So the mean definitely increased. But what about the median? So let's take a look at the median for each of these. And the median for 5, still 105. The median for 12 was 98.5. And the median for 12 is still 98.5. The median for 30 is 101.5. And the median for the new 30 is still 101.5. So the median didn't change. Remained mostly constant. Okay, so that's one observation, that as when I increased the mean, I changed that one value from 107 to 170, the mean went up quite a bit. It went up a lot more when my sample size was smaller. Didn't have as quite a big effect when the sample size got bigger, but the median stayed the same for all 5 data sets. Comment on the role the number of observation plays. That's what we just said, right? Let's see what we got here. So for me, let's think about it in my head first. As the sample size went up, this misrecorded value didn't have as much of an effect. So let me see what we got here. As the sample size increased, the impact of the misrecorded value remains the same. Nope, it went down, right? It decreased, which would be B. So I hope that helps.